Alkali metals and their physical properties. Alkali metals are first group elements and the elements present in them are lithium, sodium, potassium, rubidium, cesium and francium. Among this, sodium and potassium are most abundant and francium is radioactive. Okay. Next, their electronic configuration is ns1. Okay, because one electron in its outermost shell. Outer electronic configuration is ns1. Okay. Next, atomic size and ionic size. Alkali metals has largest size among the period. Largest size. Among all the periods. Okay. And their atomic size increases down the group. Increases down the group. Because the number of shells increases. Down the group, number of shells increases. So, the size, atomic size or ionic size also increases. Next characteristic is ionization enthalpy and electropositive character. Ionization enthalpy and electropositive character. In this case, we know these alkali metals have larger size. So, they have lower ionization enthalpy. Lower ionization enthalpy. Okay. So, down the group, size increases. Okay. So, ionization enthalpy also decreases down the group. As ionization energy decreases, electropositive character increases. Okay. Electropositive character is more in the case of alkali metals and down the group electropositive character increases because size increases. Okay. And the stable oxidation state is +1 because their outer electronic configuration is ns1, they can lose 1 electron. So, stable oxidation state. Stable oxidation state is +1. Okay. These are the important properties. Next characteristic is hydration enthalpy. Hydration enthalpy. What is hydration enthalpy? The amount of energy released when 1 mole of ion undergoes hydration. Okay. Amount of energy released when 1 mole of ion undergoes hydration. Okay. So, as the size decreases, the smaller the size, greater will be the hydration enthalpy. Okay. So, in case of alkali metal, down the group size increases. Okay. So, lithium ion is having more hydration enthalpy. So, it is because it is having smaller size. So, the order will be Li plus is having more hydration enthalpy than Na plus, then potassium ion, then rubidium ion, then cesium, etc. Okay, this will be the order of hydration enthalpy. Okay, due to the smaller size, lithium Li plus ion is having more hydration enthalpy. So, lithium salts are more hydrated. Example, lithium salt LiCl. LiCl2H2O is an example. It is more hydrated. Okay, because of its smaller size, this hydration enthalpy is high. Okay. Physical properties of alkali metals. First point, they are silvery white. Then they are soft and light metals. Soft and light metals. Okay. Soft and light metals. Due to their larger size, they have low density. They have larger size, so low density. Density is less, but density increases down the group. Okay. Density increases down the group. Next point, but in the case of, if we take potassium and sodium, there is a difference. Potassium is lighter than sodium. Okay. Potassium is lighter than sodium. Potassium is lighter than sodium and lithium is the lightest metal. Okay. And lithium is the lightest metal. Now, what about melting point and boiling point? They have larger size, so they have low melting point and boiling point. They have low melting point and boiling point. And also melting point and boiling point decreases down the group because the size increases. Next, flame coloration. Next important physical property, flame coloration. Flame coloration. So when heat is supplied to an alkali metal or its salts, what happens? The electrons are excited to the higher level. Okay. When they return to this original level, radiations are emitted. Okay. Radiations are emitted. In the visible region, and these radiations are in the visible region of electromagnetic spectrum. Okay. Visible region of electromagnetic spectrum. So what happens? Different colors are obtained. Okay. So the different metals, these alkali metals can be identified using these flame colors. So lithium gives crimson red, then sodium gives golden yellow, potassium gives violet color, then rubidium gives red violet, then cesium gives blue color. So we can detect the different elements using this flame coloration. Okay. Next property is photoelectric effect. Photoelectric effect. Alkali metals also shows this photoelectric property, that is, when light rays falls on them, electrons are lost from the surface of the elements. Okay, this property, except lithium, all other metals shows this property. Okay, so when light rays falls on these metals, the light energy absorbed is sufficient for them to lose electrons from the shell. Okay, so they lose electrons, and this property helps cesium and potassium. Cesium and potassium are used as electrodes in photoelectric cells. So cesium and potassium is used as electrodes in photoelectric cells due to this photoelectric effect, this property. Okay, except lithium, all alkali metals shows photoelectric effect. Okay.